Okay, so phase one is done. We've created our CoreOS cluster. And if these are pretty big machines, we can actually run a lot of applications. We have a decent bit of computing power. I did the smaller machines. Your choice on whether you want to do a lot of smaller machines or less large machines. It's really up to you. But we've got 4 machines running. So the next thing we're going to do is we're going to run some instances of web apps. Now, we don't want more than one web app running on each machine, at least not at first. Depends on how powerful those machines are. We might be able to run 4 of each web app on there and load balance between them. But for redundancy's sake, you at least want different copies of web app running on different machines. That way, if they're all running on this machine and this machine goes down, well, that's a bad idea. We want some running on different machines. So let's go ahead and get to how to run fleet services. Now, if you remember from my diagram, here's the holy grail. This is what we're going for. This whole CoreOS cluster is hidden behind our private network. Nobody can access this from the outside world at all. And then you want to have your one public-facing server that the outside world does have access to, and he's also on the network and can proxy into all the IP addresses within your CoreOS cluster. Now, on DigitalOcean, you don't have true private networking because every one of these has a public IP address, but you can set up IP tables to block pretty much all access. So that's, if you want to research that, it's very simple to do. Just look up, CoreOS IP tables, DigitalOcean, and you'll have all the information on that. Amazon AWS, Rackspace, lots of these places will give you true private networking. So we are SSH'd in. That's excellent. Let's go ahead and exit out of that CoreOS machine. And so now we just need to get fleet control installed on our machine so we can actually talk to the fleet cluster, the CoreOS cluster from our computer. So I'm on my computer now, and you can just, if you have Homebrew, you can just go brew install fleet control. So that's going to get fleet control installed. And then you just have to do one thing. You have to snatch any one of these IP addresses, and you need to create a fleet tunnel environment key. So export fleet ctl tunnel equals. Oh, did that not copy? Okay, let's copy and paste. There we go. So export fleet control tunnel equals, and then one of those IP addresses. They're all going to work. And now I can go fleet control list machines, just like I did when I was on the CoreOS cluster. There we go. So there's all 4 of my machines. So what Fleet's going to do for us is, I don't want to have to think about which machine to run a service on. I just want to say, hey, run 3 services and be done with it. So Fleet's going to handle that. So I'm going to say, hey, run 3 web services. It's going to go 1, 2, 3. And then Fleet's also going to manage failover. So if this machine goes down, Fleet's going to notice, hey, Web 3's machine went down. Let's rerun Web 3 over here. And if there was other things running on this machine, it's also going to rerun them on different machines. So Fleet's going to handle both scheduling and failover for us, which is great. Let me show you what a Fleet service file actually looks like. Let's go sumapp &.service. That's the name of my file. And the ampersand means that I can run copies of it. Any service that you want to run multiple copies of, you're going to want to put an ampersand at the end. I know that's really small on my screen, so you might not be able to see it well. And so basically here you got your description. And because it's an ampersand service, I can run copies. So every %I is going to get a number. So when I want to run this service, I'll say, hey, run sumapp 1, 2, 3, 4, and 5. And they're all going to run this exact same file. And then this will turn into 1, 2, 3, 4, or 5. So that's kind of what that %I is there. So it has a description. It's running after Docker. And this is pretty much my Docker command. I'm going to do docker run. And then here's the name of my Docker command, my Docker image. So this should look pretty familiar if you're familiar with Docker. Before we start the service, we want to kill any existing version of sumapp1. And then we want to remove sumapp1. And we want to pull my image, the latest of Will Stern node sample. This is a basic Node.js application. And then we want to go ahead and run it. And we want to inject the app name in there and stuff like that. So, and then also we want to stop our app whenever the service stops. We're going to go ahead and stop our Docker container. So that's a service file. It's very simple. I'm in the folder with this service right now. I can go ls. You can see there's my sum app at service. So I want to actually push this up to Fleet right now. So I just go Fleet control submit sum app at, or I could do at.service. It's smart enough to know that .service is the default. So there we go. Now it's in there. So if I go Fleet control list unit files, so I have a unit called sum app that it's now aware of. So now I can run this. So I can go Fleet control run or start sum app at 1. Whoop, sorry, missed a T in there. Fleet control start sum app at 1. So there we go. Now it's running sum app 1 somewhere on one of my CoreOS nodes. Awesome. Let's go ahead and run 2 more. Let's go sum app 2. Actually, let's do this 2.4. So I'm going to run between 2 and 4. So now I'm going to actually boot up 2, 3, and 4. That's a way to do multiple things. I can also go, and every once in a while, Fleet gives you this error. I need to look into what exactly that is. Let's go ahead and clear this out. Fleet control. You can also do start sum app at 1, sum app at 2, sum app. You can do it like that as well. So let's do list units now. So you see that it's activating all 4 of them. So what activating means is that it's allocating the resources. It's kind of figuring out, shall I put it here, here, here? Okay, let's do 1, 2, 3, and 4 there. And then it's going to start running, there you go, running start pre is where it's at. So start pre means that it's killing, that it's removing, and that it's pulling. That's probably what it's doing right now, is doing that initial Docker pull, which you remember that first Docker pull takes some time because it's getting all the base images that your Docker image is built on. So this will probably run for about, I'd say 30 seconds total. And then you're going to start noticing that some services have started. I will keep doing this in an impatient way. And it also shows you the IP addresses that it's going to be starting them on. Come on. Still activating. Still activating. Come on. There we go. Got one active. So I can actually SSH into this now. I can either grab this IP address and SSH in, or I can use Fleet control and let it SSH in for me. Fleet control SSH into sum app 4's box. So now I'm actually into the box that sum app is on. I can run Docker PS and see, there we go. I've got sum app 4 running. So I could actually take that IP address. What is it? 32768. And which one are we on? There's my IP address. So let's go take this. What is that again? 32768. Let's go to 32768. There you go. I'm now viewing sum app 4. Okay, another cool thing I can do is I can actually journal the logs of that. So I can go Fleet control journal sum app at 4. That's going to give me some of that log output. So you can see there we are. There's my log output from my web app. Let's go ahead and hit up a few more. I just refreshed it a couple more times. And you can see there's all my latest log information. I can change how much, how many entries I want to see here, but that's really nice. So I can get logs from any service real time. So that's basically how Fleet works. And then in the next video, let's go ahead and look into Flannel and how these things are going to talk to each other.